Welcome, guys, to the fourth target here in Unit 3. And so far, the first three targets have really been about laying a foundation for what we're going to start digging into now in Target 4. We've talked about slope and rate of change and all of that stuff in Target 1. We learned about a relation and domain and range and some of that new vocabulary and what a solution of a two-variable equation even looked like. In the third target, we started really digging into functions and how to know when a relation was a function, and then how to communicate and work with function language, function notation. And what we're going to be digging into now is working with our two variable equations, but working with them in very specific forms. All right. Now, some of these you may have actually seen before. Well, we definitely saw them first semester, but even before that, you might have seen some of these. These formulas are going to be super important here in the last couple sets of notes going forward. It is going to be really pivotal that not that you memorize them. We're not going to ask you to memorize them, but we are going to ask you to know what they mean and be able to communicate using them. All right. We're really not going to cover a lot in this first video. Mrs. Custodio is going to do some of the heavy lifting on the second page here. What we're going to talk about, we're just going to kind of walk through each of these forms, and we're going to talk about what the variables are and what they represent and what they communicate, because that's really going to be the most important thing. All of these, if you look, guys, at the 5 formulas that we have here, notice there are no numbers in any of these equations. These formulas are all variables. And so what happens is these formulas are then used to create and read equations that have numbers in them. And that's what you're going to see on the second page with Ms. Custodio. But guys, it's going to be pivotally important that we understand what each variable in each formula is communicating to us. And you're going to see there's going to be some overlap. There's definitely some commonalities between some of these formulas, but it's going to be really important that we know them. So let's just start talking here. And the first formula is the most common one, the most widely used linear formula, and that is slope-intercept form. Now, the reason that it is called slope-intercept form is because the variables in this equation give us the slope and intercept. All right, so we can see this as y equals mx plus b. Notice there are 4 variables here, right? 4 variables that we've got to understand what they're telling us and what to do with them. The first one is m. That is going to be slope. Why in the world m is the variable for slope? I don't know. I didn't make it up. Some guy did that's probably been dead for a long time, so you can't even complain to anybody. It is what it is. That's what we're going to be stuck with. But whenever you see the variable m, that's almost always going to be your slope variable. All right, now b is the trickier one here. This constant here, b, and notice, guys, m is a number that's being multiplied by x here. So that's how you can always tell m. M will always be multiplied by that x variable. B is a constant. B is on its own, and it is not the y-intercept. I don't care what textbooks or other teachers or people have told you. The y-intercept we're going to talk about is an ordered pair. B is the y value or y coordinate of the y-intercept. B is the y coordinate here. All right. And here's another really important thing, guys, that x and y must stay variables. So when we start using this formula, you are never going to put a number in place of x and y. They must stay variables, because here's the deal. X and y have to represent every single possible solution, the infinite number of solutions to the equation. Remember, a solution is an ordered pair. So by x and y staying variables, that gives you the possibility of having an infinite number of ordered pairs. All right, so that's slope-intercept form. This form is going to be very useful when we either know or we want to know the slope and the y-intercept. Let's talk about point-slope form. So now, if you notice in point-slope form, guys, there's 5 variables. It's a little bit more complicated. Right, there's a little bit more to keep track of and remember here, but you're going to see it's a little more wide-reaching. It's a little more usable than point-slope form. So again, m is our slope. And we have the word slope there. M is our slope. Now, here's the difference. Instead of just having one variable, one constant for b, we have 2. We have h and k, minus k, minus h. And what this is, h and k is a solution a point of the equation. And here's the key, guys. It can be any ordered pair, any point, any ordered pair can work for h and k. Where in slope-intercept form, it's only the y-intercept, right? In point-slope form, it's any point. Doesn't matter what point it is. It doesn't matter what ordered pair, what solution. Anything will work. And we can see here, x and y, just the same as we had before, must stay variables. All right, so m is the same, and x and y are the same. Really, the big difference between slope-intercept form and point-slope form is slope-intercept form has one constant, b, which comes directly from the y-intercept, and we'll talk a little bit more about that in a second. H and k, point-slope form has h and k, two constants, but it can be any ordered pair. So it's a little bit more complicated, but it actually gives us a wider range of options of when we can use it and work with this formula. All right, horizontal and vertical form. These are the easiest if we can remember them and keep them straight. Here's the deal: if you have a vertical line, all right, you have no y variable. Notice there is no y variable in vertical form. All right, h is the x coordinate of any point in the equation because every point will have the same ordered pair. So, for example, if I have a vertical form with a point 2, 1, well, then it will also be the x coordinate 2, 2. It'll be the x coordinate 2, 3. That's not even the number 2. That's not a number at all. 2, 4. And so forth. All right. Every ordered pair of a vertical line will have the same x coordinate, which we call h. All right. And then we have a little acronym here to help us remember what we know about a vertical line. It's called VUX. VUX. Vertical line has an undefined slope, right? M equals undefined. And our formula is x equals h. So if that helps you kind of remember that, vertical VUX, right? We come over here to horizontal form. Horizontal form is y equals k. Now notice there is no x variable. There's only the y variable there. All right, same deal we had with our h value we have with k. In a horizontal line, in the horizontal formula, the y coordinate is always the same. So if I have negative 2, 7, I'll have negative 1, 7, 0, 7, 1, 7, and so forth. Notice the y coordinate, the k value will always be the same. So y equals k is our horizontal formula. We also have an acronym to help us with this, and that is called HOY. Ahoy, hoy, right, as Mr. Burns would always say. H is for horizontal. The O is actually the number 0 because our slope is 0, right? And then our formula is y equals k. So horizontal and vertical form are really easy because there's only one variable, x and h. And just like above, guys, just like in the other formulas, x and h stay x and h. You have to have an x in vertical form. You have to have a y in horizontal form. It's the h and the k that have a value filled in based on, right, based on this value here is going to be the 2 in this example, right? And then over here, this k value here would be the 7s. All right, we've got one left, and this is kind of like the odd duck of the family here. This is the black sheep. This is the one that really doesn't have anything to do with the others. Notice the first 4 guys all involve slope in some way. Slope, intercept, and point slope both have m as a variable. Vertical form and horizontal form both still have slope, even though m's not in the equation. It's still an important thing that for vertical, the reason it's vertical is because the slope's undefined, and the reason it's horizontal is because your slope is 0. Standard form does not have slope involved at all. Okay, notice here, slope is not part of standard form. What standard form is based on is the x-intercept and the y-intercept. Standard form also has x and y on the same side. Now, x and y are still going to be stay variables like always, but notice x and y are on the same side. X and y are on the same side, and that's the only formula where that happens. All right, so what we have is we have a and b, which are numbers, A is being multiplied by x, b is multiplied by y, and then c is a constant on its own on the other side. These are all integers. These are all going to be numbers that we can identify in a specific equation. And we use those numbers to find the x and y intercept of the equation, which allows us to know some information, allows us to be able to graph things and work with different situations that we would need this formula. The key is our formula, guys, is c over a comma 0 gives us the x-intercept. So if I know what c is and I know what a is, I can divide the c over a to get the x-coordinate of the x-intercept. And 0 comma c over b will give me the value of the y-intercept there. Again, this will make a little more sense when Mrs. Custodio kind of works with some of these things in the next example, and we start actually using these formulas to graph in the 4b notes. All right, so guys, that was kind of a detailed walkthrough of these formulas here. Again, if you kind of forget something, you can always rewind and come back to that. But before we end our video today, I do want to talk about two important vocabulary words that we referenced especially in standard form there, but one of them we definitely referenced in slope-intercept form, and that is the vocabulary word of an intercept. All right, now an intercept is a specific type of point or ordered pair. All right, solution, point, or ordered pair, right, of an equation, but it's specifically located on either the x-axis or the y-axis of the equation. So these are very special points because in a line, there's only going to be one of each. Now, as you get to different graphs, you might have more than one x-intercept. We'll talk about that. But for right now, if we were to graph a line, these are only going to happen once. So let me draw a line here, and let's just have it go like that. All right, we'll call it that. So we can see this green line crosses the y-axis up here and the x-axis down here. So I'll do this one in purple and this one in red. So the purple point here is my y-axis because that's where we're crossing the y-axis, or sorry, this is the y-intercept because that's where we're crossing the y-axis, and this is the x-intercept because that's where the green line is crossing the x-axis. Now, some important things about an x-intercept, and I think I said that backwards, guys. The red point is the x-intercept because we're crossing the x-axis. There's a lot of x's in there. It gets confusing. The key, guys, and the thing we have to understand that's really important about an x-intercept is if it's on the x-axis, the y-coordinate will always be 0. If a point is on the x-axis, the y-coordinate will be equal to 0. All right, that is a guaranteed. It has to happen. It's just the logical what happens if we're on the x-axis, we haven't gone up or down at all, so that y-intercept is 0. Now, the x-coordinate could be a whole bunch of different numbers, right? In this case, our x-intercept is -4, 0. All right, but it could be the x-coordinate could be any number on the x-axis as long as the y-intercept is indeed 0. All right, so the y-intercept is the exact same thing. It's just flipped because now we're on the y-axis. It's the x-coordinate that is going to be 0. So I'm going to cheat here and save us a little bit of time. Instead of having me rewrite this here, I'm just going to duplicate this, change the color to match what we did, and do a little erasing of the axis and the coordinate there. And because if a point is on the y-axis, the x-coordinate will always be 0. So here's the deal, guys. If you ever see an ordered pair where the y-coordinate is 0, it's automatically an x-intercept. And if you ever see a point, an ordered pair, where the x-coordinate is 0, it's automatically a y-intercept. And that's just a really important vocabulary word and a really important fact that is not just going to be useful here in algebra, but guys, you're going to carry that forward maybe a little bit into geometry, but really, really big into AAT going forward. All right, so that's what we got. Mrs. Custodio is going to pick up and kind of actually use these formulas and work through some different specific equations. But again, if you got questions on kind of this general knowledge or vocabulary on X and Y intercepts and kind of what we walked through in the formula, please shoot us an email and or Zoom chat with us, and we'll be happy to help you out. We'll talk to you again soon.